Welcome back for another Girnar video. I went through the rest of my notes here, had some thoughts, so I thought I'd share them, highlighted stuff along the way. Sorry I don't have this on the screen. It would be cool if I was editing. It would be so much work for me to edit this, dudes. It's already a lot of work to then, on top of that, take the video, insert the text on top of it, and then the key critical part, my computer cannot handle rendering this much content, whereas just hitting record is just done. So for me, it's significantly easier to just do it this way. So unfortunately, there's some side effects where I won't have the information up on the screen, but I will be reading it. So these are just research papers on Mount Girnar that I was reading, and a couple of the previous ones I got a little tangent sidetracked, but I'm back on here. This is Suba Rao 1971 A from John Wayner's book. He references basically all these are just references from his book because I just could not find. They were almost all in some 1970 Indian geological book that's hundreds of pages long. I'd like to find it online. Maybe he has the links, but to access it, it's almost impossible to find most of these references. So all I have is what he quotes for most of it, so it's all from that book. Anyway, so Subarao 1971A, which is just the first one from 1971 that he lists in his book because they have multiple papers in that year, and he lists multiple papers of theirs for that year. So I don't know what the paper is. It's in his book. And then Subarao 1971A. The eruption of lavas, which are mostly basalt, was followed by a laccolithic intrusion of gabbro, causing the flows to assume quaquaversal dips. Quaquaversal. Quaquaversal. I don't know if I say that right. The way it has these four sides, dips, dip, 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 quaquaversal around the mountain. And it's saying the eruption of lavas, which are mostly basalts, so most of them are basalts. This is all basalt. All the green out here is all basalt. This is basalt. And then these are the things that are not basalt, pretty much. Just mostly here and here. Everything else is basalt. So the eruption of lavas, which are mostly basalts, was followed by the laccolithic intrusion. So let's just look that up. It is like a dome-shaped thing. So kind of just a mound. So if we go back to the concept that there's currents coming in, pushing a mound, it essentially is creating a mound, not just at the surface level, but physically underground as well, which is then in things like this. I thought I took a picture of it at this point. There it is. This one, Kayla et al. 1980, also referenced in his book, where there is a Mount Girnar Hills. Underneath it, 50 kilometers depth, is this mound that just rises up because these currents are flowing in, converging, and causing basically the densest things to move to the center. Kind of like gravity in a way. Just moving the densest things to this center system that then accumulates where the currents are. Over here, the particles are by themselves, so they're freely moving in the currents, but then they all move to this pillar that's forming and become part of it, and then they stop moving. So then they sit in this pillar and grow in the pillar until they break through the basalt's overlay, which initially perhaps forms as a crystallization process of the gabbro on the top here. This pink section, which I realized was in these notes, there's some subtleties that maybe I should call it gabbro and not olivine gabbro. Like it's gabbro that then, as it cools, leads to channels of olivine, basically. So it's almost like it's filled with these channels of olivine from its cooling, but it's really a base of gabbro. It's not like a mixture olivine gabbro as it's kind of portrayed when I say it that way and when I read it that way, and just don't understand it fully, so present it that way. So just there is, it seems, a sort of intrusion aspect to the olivine within the gabbro. Okay, let's keep reading though. So the eruption of lavas, mostly basalts, was followed by the laccolithic intrusion. So I would say it was followed by the accumulation of this intrusion at this drainage point where the currents are flowing, which was causing the currents flowing, was causing the flows to assume a quaquaversal dip. Okay, so then due to the thermal, this is back to the quote, due to the thermal metamorphic effect of the gabbro, the basalts attained a granulitic texture and are now found in the form of basic granulates. So they're like cut up. It's like the larger systems had so much current going through here that it kind of broke it down into subtler particles. That's how I read that. Thermal metamorphic effect. The basalts attained a granulitic texture, or it made it more dense into larger particles. Maybe it's not. It depends on if it's usually granulitic. It says basic granulates. Basalt, granulitic basalt, high grade metamorphic, high temperature and moderate pressure. So compacted, I guess, formed into larger grains to essentially enough pressure and temperature to produce larger grains. Okay. So that's due to the thermal metamorphic effect of the gabbro, the basalts attained larger grain. I mean, I don't know if I'd agree with that. That seems kind of unnecessary. Like the whole region is just it's just so many there's currents coming in compacting it, so all of the region, that's why it's like mounded up basalt. Even like the basalt's not just flat across here leading up to the olivine gabbro. It begins to have these bumps and ridges and mounds and hills of basalt. I mean, probably with underlays of other material, in part leading to the upwelling, but not completely. And probably also just simply, just like a galaxy. I mean, if you picture it like the center of a galaxy, like the particles around the center are probably going to be like the most dense, like the sun. It's going to have like the most particles per space, and then like quickly outside of it, it becomes just like a flat plane relatively outside of like the solar system, let's say. Like it becomes much more just uniform with some scattered features that are based on larger currents. Okay, okay. The tensional fractures formed due to the intrusion of gabbro were filled with the same magma, giving rise to olivine dolerites. The laccolithic intrusion of gabbro was followed by the intermediate and acid intrusions. The latter assumed a ring dike form by the infilling of the circular fractures developed by the intrusion of gabbro into the lavas. Or larvas? I'm not sure. I think it might have actually legitimately had an R for some reason and not been lavas, and I was like, but either way, that's let me try to reword this maybe, and therefore maybe not sound like I'm just reading something. That as this gabbro, this pink section, is building up and essentially causing the inner flows to have like a space where they can't flow into, like it begins to open up a space. The currents are like running into it and going around it instead. It begins to open up this space. And then the tensional fracture, so any just like faults in the structure, like because it's not supported by just perfection underneath it, it has like voids, there's all sorts of things going on, so tensional fractures occur in the gabbro. Tensional fractures form due to the intrusion of gabbro, or maybe then in the basalt, I'm not sure, were filled with the same magma giving rise to olivine dolerites. To me, that means in the gabbro, because the olivine dolerites, I believe, are playing into making it olivine gabbro. I'd imagine. The laccolithic intrusion of gabbro was followed by the intermediate and acid intrusions. So the gabbro was followed by the intermediate, which I believe is the monzonite diorite. And then the acid intrusion is the granophyre ring dike. Formed by the infilling of the circular fractures developed by the intrusion of gabbro into the lavas. So as this rises, as the gabbro rises through both the layers, I guess maybe there's like a granophyre. It's coming maybe from the mantle itself, the gabbro. Like it's upper mantle lithospheric material, and it was transported by a deep mantle basalt material, basaltic type thing. That's when it's penetrated through the layers. It brought with it granophyre, which was perhaps from the basement rock that was caused to just kind of go out to the boundary, like by the currents, maybe even like it just got brought out over time. Even if it had like emerged here, it could have ended up at the boundary. It just came off of the upwelling of that, maybe. I don't know. Let's keep going before I get stuck too much. Olivine gabbro, 30.7 kilometers squared. So this, I just thought that it was interesting to mention. So this pink section is 30.7 kilometers squared. Diorite, which I would assume they mean to be just Mount Girnar itself, the monzonite diorite, is 4.35 kilometers squared. This is from Gupta, 1998. And then the granophyre, which they call acid porphyry, PORPF, or PF, PORPHYRY. Periphery, 20.2 kilometers squared. So that's 5 times as much as the or area, at least area of the Girnar itself. I guess that's only area, so it's not really counting for the total mass due to the elevation difference. The Deccan Traps, Kayla et al., 1981, who is this paper also. Same author, different paper. That says the Deccan Trap thickness was found to be relatively large west of Junagadh, about 1,300 near. So let's bring up the map. West of Junagadh, and then they say about 1,300 meters near Navi. Right where that comes out, right here, Navi Bandar. 1,300. So the thickness of the basaltic layer is 1,300. It's just thicker here than it is. It says 900 between Mahayari and Junagadh. Here's Junagadh on the edge of Girnar. Mahayari, I couldn't find it. It's I presume since Navi Bandar is over here that it's, say, here-ish in this region. Here, something around here. So around this region, it's only 900 meters. 1,300 meters, 900. So it's starting to slope away, which makes sense because this is the polygonal boundary, and slope back inward towards Girnar. But then over here, it says east of Girnar, it thins to around 400 kilometers, or 400 meters. 900 then near Bagasara here, which is at this tip of the lightning bolt going into Girnar, where it's going into Girnar specifically, which is interesting. So it's almost like the energy comes through here, leading to like an increase in, it's even like a sky with sort of lightning looking light. It comes through here, though, and goes into Girnar, so it kind of would make sense that it would, over time, it would build up a mound generally here that would fall off towards Girnar, but maybe as it ends, it just leaves a mound here. Whereas over here, Amreli, it says, is 350 meters, so it's significantly thinner, the Deccan Traps over here, than it is over here. That's just something of note, which kind of makes sense with these currents, I would say, just from here, like because there's a current coming this way, this larger current initially that's just filling space over here, it would produce a mound here and start to build a wall that then reflected the current back. So then it would start to build a wall here too, but it just start to go back this way to a point where it would be lower over here than it was over here, but then it reaches Girnar, and then we gotta deal with that the storm is coming this way and discharging, so it's really moving material away from this region, and so that would kind of make sense for why this would only be 350 meters, where this is 1,300, 900, and then here's 900, so it kind of makes sense, like at the flame tip, that there would be like a bulk of energy, of mass, that leads to an actual elevation difference. And then again, down at the tip of the flame, back to around 400, kind of makes sense also. So, like, those make sense with this. Okay. Deep crustal depth in this region down to Moho of Girnar displays Horst Graben, which is, or Horst grabbing these things. Okay. Mount Girnar is traditionally written of as a horst with surrounding grabens. Whether or not it's actually that whatsoever, besides the point. Girnar, though, is considered the horst, and the graben is the areas around it that are considered to be depressed based on, again, this is the same author, they're just referring to this. Horst, graben. But it says it displays the crustal depth in this region down to the moho. Displays Horst graben. So, like, they're basically saying this mountain goes down to the moho, to the edge of the mantle. Crazy. Although I know in one of the other videos I still had to check that paper out. It basically says they had a totally different result in some way. I don't understand what the way was. Maybe they still generally see these reflectors, but maybe not. And the moho boundary is 35 to 42 kilometers in depth. So, Mount Girnar is not elevation Mount Girnar. Hey. No, I mean, this mountain is just perfection, is it not? Is it not? I don't know why it's saying 420. I guess that's its base elevation. Its peak elevation is base elevation is 420. It's like this. That's the way up the mountain. Gotta get to 420 first, then you're on level playing field of the plains of Cathiowar, and then make it up the mountain, which is another. It's only 3,500 feet. It's not that high, but this mountain is 42 kilometers in elevation. How deep is Mount Everest? Yes. Cracks open rocks from which allowed the researchers to pinpoint the depth of the Indian continental crust. Mount Everest in the Himalayas, the world's tallest mountain, rises 8,848 meters, or 5.5 miles above sea level. Researchers already know depth of. Maybe I skipped it. Let's see. I don't know. Mount Everest. I doubt it reaches the Moho. I doubt that any of the Himalayas reach the Moho, really. Because it's not really visible. Yeah! Just saying, which really would mean that Mount Girnar is just a fucking mountain. It's 40-kilometer tall mountain plus another kilometer above. It's 420-foot elevation. Nothing too bad. It's only a kilometer in elevation. It's 1 unit in elevation. That's pretty interesting, actually. Okay. Various reflectors in the vicinity of Girnar Hills are badly disturbed and show updip towards the hill on its sides. Also, Kayla et al. Suba Rao, 1964. Semi-crystalline mass probably moved up, disturbing the lava flows of the area to give rise to the main parts of the Gabbro intrusion in Girnar. Semi-crystalline mass. So, essentially, these structures, semi-crystalline structures being uplifted, they're kind of suggesting. I assume that moved up, uplifted, disturbing the lava flows. I mean, to me, it's more so building a mound to the point where it just protrudes beyond the surroundings of basalt that are just a current flowing like an ocean. Like it's just built up a mound tall enough to protrude outside of it. Then that mound was composed of olivine gabbro, because that was what was able to, under the pressure of the currents, be moved to then accumulate there. At least on one layer, because there's multiple layers probably, which then is leading to the monzonite diorite. Like an undercurrent that's pulling not olivine gabbro materials, but monzonite diorite materials into another uplift. Just some thoughts. Okay. Girnar comprises olivine gabbro, diorite monzonite, lampreyphires, and nepheline cyanite. Nepheline cyanite? Arranged in the sequence of crystallization. This is Bose 1971b. Arranged in the sequence of crystallization, not in the sequence of age. Like if this is a volcano, because it's kind of a laccolith, it's generally described as like a volcanic dome laccolith that has eroded in some way. That's millions of years old, and that's about all that matters. It's not caused by a storm passing through the region that then punctured the mantle. It just doesn't capture the essence of what's going on if we just say it's a laccolith. But it's called a laccolith traditionally, which generally just that it had this like accumulation of a gabbro here, and how exactly it got there is just kind of considered to have funneled up directly from some channel, like some vent. But I would suggest that it maybe that, but maybe also it was brought there from the currents colliding from the sides, bringing in the denser materials of the overall currents of the basalt that were mixtures with other things that just got separated in the process by the vortex and so on. So then they say, arranged by olivine gabbro, diorite monzonite, lampreyphires, and nepheline cyanite or nephelite cyanite. I keep reading it as both. Sorry, guys. In the sequence of crystallization. So, like, the fact that they're crystallized in this way, and it's important to understand, are not dated, like, today and tomorrow. Like it would appear like this was one event. Like, it occurred and then it was done. Like, why? Yet it lasted millions of years. Like, if we take the general plate tectonic interpretation, then this was a slow and steady process. That was millions of years where there was an intrusion of olivine gabbro, and then at a later point, the same vent was used, and that time diorite monzonite came out. And in the process, some rings were formed somehow, and it's really mostly just coincidence and erosion, though. And then next mountain, we're done. Next mountain, check, check, we did it. We did it. Time to party, guys. We did it. Didn't look at all. uh, Laccolith, though. So, I mean, not quite the same, but probably a related process to a degree where the term laccolith is used. Maybe it's a vent coming out, but maybe it's also some kind of compressive force in that plane leading to some, like, disc. Like an inner disc, inner ring. Okay. So I wrote, this is strongly suggestive that the millions of years between the formation of each rock is invalid, because they would be arranged by their ages largely if they were separate events across millions of years. Like, to say that they're arranged by their crystallization sequence is to basically be like, it's a coincidence that they emitted that way. I mean, maybe we can kind of explain it like, well, underground in this vent, it was crystallizing, and what vented first was the first crystallization thing, and then the next thing, and then the next thing, and there, voila, what's the problem? Except for that I don't know what I'm talking about. Not me either. Bose, 1973. Sequence of crystallization of the co-magmatic plutonites as developed solely within the Girnar Hill. They say the sequence is gabbro, diorite, lampropheric rock, and then cyanite. So first was the gabbro, then came the diorite, then came lampropheric rock, which was essentially, as the diorite cooled, as we'll find out, it opened up channels in it, like a cooling system would. It would allow channels, and then in through those channels comes lamprophire, and as it's cooling still in through those same channels comes nepheline cyanide that then brings the lamprophire fully through, so that it's exposed, embedded in xenoliths of nepheline cyanide, whereas the cyanide is not like that. It's just it's the last emission through the channels, so it doesn't have something that's bringing like its portions through. So gabbro, diorite, lampropheric rock, cyanite. Spatially, gabbro is developed as the outermost member of the suite and may be considered to have crystallized closest to the vent wall. Not sure what to make of that. I mean, to the vent, to the inlet-outlet air wall. I mean, in a way, that's what's going on. So, yeah, I guess so. But I'm not sure if what they mean by vent wall. Okay, I guess just generally the outlet of this laccolithic emission of the gabbro, I guess. Diorite and associated rocks have pierced through the gabbro. Ghostly inclusions of gabbroic rocks are seen within diorite. So in the same way as the lamprophire is in the nepheline cyanide, within the diorite monzonite of Mount Girnar are pieces of the gabbros. So it basically just brought pieces of the chunk it went through with it and in it as part of it. There's probably basalts in it a bit too, I'd imagine. Just not to the point where they map them. Dark lampropheric rock and its immediate successor, the syenites, occur as minor intrusions, chiefly within the diorite. And then Oka, 1975. Numerous dikes and thin sheets of lampropheric fire cut the central diorite monzonite mass and the olivine gabbro of the inner valley of the Mount Girnar intrusive complex. Close association and mineralogical similarities of the lamprophyres with these rocks indicate that they are produced by fractional crystallization of the residual magma after the emplacement of the diorite monzonite stock. So basically, they're just saying this is developing the sequence of events of how all these things occurred. Sat, and 1966, and Desi 1968. I'm not sure. I guess this isn't quoted. Mechanism of composite intrusions of lamprophyre nepheline cyanide is that residual diorite magma fractioned into mafic and alkali silicic, which intruded in fissures. Lamprophyres intruded first, was not fully consolidated before silicic fraction through the same channel, which brought the cyanide, I presume. You know, it says silicic, which I feel has been associated with the granophyre. I don't know. Okay, Rockin' Paul, also known as rock and roll. Although many aspects of Mount Girnar, including age, have proven controversial, it remains the best documented Indian example of the Indian alkaline. I put in parentheses, the Indian alkaline lampropheric rock remains the best documented Indian example of association. The complex displays many noteworthy analogues with the Monterregion complexes in Canada, and especially with the Monchique complex in Portugal of almost identical age. So those are worth of interest for me for sure to check out in view of the map here. Like maybe there's some upwellings, like some, because for sure Yellowstone Nova over here sending energy into Canada up this way. And maybe there's some regions of something going on. I don't know why it would have similarities to Girnar, which seems very unique to be related to this drain and to the storm passing over top the region. Although it's very possible the storm was so high that it wasn't like directly above the ground, and also it was so large that it just had like tendrils out to literally cause the whole Earth to be in a lesser but still storm-like state where similar like currents were flowing while like eruptions occur, like Yellowstone eruption, and then a current flows over top the eruption over here, which then just shapes the region in a similar way, even though it's not where the storm is. The storm is over top the whole of the Earth to a sufficient degree where it's like the negative interacting with the positive of the Earth, and they're just short-circuiting and exchanging massive amounts of energy between them and just shaping mountains quickly and rapidly, and then like just reaching throughout the whole world doing it as possible, and something of that nature is going on. It still doesn't have the nearby mantle puncture hole, but I'm not even sure it needs to. Once the current is filling the whole Earth out from this hole, it's everywhere, and it's kind of applying a pressure upwelling on the earth in places that probably just breaks through due to the pressure and the novas going off and just discharges out into the surface where then the storm is able to discharge through as well and just bring a equilibrium. Just get this is just essentially making the storm no longer a storm. Equilibrium, that's it. At least temporarily. Okay. I skipped all this. Sukaswala, something like that, 1982. The first in the eruptive sequence was the Gabbroic magma. It's just another reference to the sequencing of this. The Gabbroic magma first through the basalt and settled in the form of a laccolith with a basalt cover. This intrusive mass imparted quaquaversal dips to the host base basalts and perhaps also developed the radial and ring fractures in the basalt. These ridges are saying maybe are related to olivine gabbro. They don't even say it with a certainty though, say perhaps. In the second phase, which maybe suggests that they also are related to other things like the crystallization of this mountain, where it really is like a crystal, and there's subtleties of that nature going on in its formation process. Okay. In the second phase came the acid magma, which is the rings, silicic porphyries of base on the bows, which I mentioned, I guess, which filled up the peripheral ring fractures and call it xenoliths of basalt and gabbro. So the granophyre brought up basalt and gabbro, and also xenocrysts of calcic plagioclase and augite. I think that's where it's referring to. I might be mistaken. That might be referring to here or something. I don't know. It may safely be assumed that the gabbro magma had cooled and consolidated well before the eruption of the acid magma, for there does not seem to be any evidence of mixing or assimilation, although they don't really consider the separation of vortices, of course. So, I mean, it doesn't have to be that, but that does sort of suggest that they were talking about this ring as the silicic porphyry ring. Basalt dolerite dike phase lamprophyres found its way along the fracture planes in the gabbro, developed during its cooling process. As this is cooling, it's fracturing, and then lamprophyres are finding their way up through it. Along the fracture planes in the gabbro during its cooling process. In the last phase, then come the cyanites, traveling along the weaker planes of basalt dolerite dikes, forming composite dikes of lamprophyres and cyanites. So again, just the same repetition of that this is something that's occurring here. It's just related to its cooling process. So as the energies are cooling, it's just causing like a bubbling up of things trapped inside that are just under higher and higher pressure, and then they find a way out through a path of least resistance and just emit through those channels, creating these just probably not remotely where I put them, but generally on Mount Girnar's Peak and on the ridges, along the ridges, and other places for sure that I didn't put them. Obviously, I don't know. Really, I'm just going off of people's words and maps. These are word-based, saying that there's nepheline cyanite along the ridges and in the mountain intermixed with Lampro fire. So it's just based on words, and more so on on the southwest side of the mountain. So I'd put more dots here, but it's really not like it's not like I know there's one there at all. So there's that going on. But okay. Let's go on Chandra 1995. The field petrographic and petrochemical data reveal that the rock types in the Girnar layered series bear a parent-daughter relation through a process of magmatic differentiation. So it's just one magma that had, like, it probably, like I said, mentioned, it probably had upper mantle and lower mantle, solid and liquid materials within it that were flowing and differentiating. The materials being differentiated were because of what they were just moved to certain locations. This is interesting. I put this hill here, Jada Sankar Hill, which is hard to locate. I'm not exactly sure. They wrote it Jada Shankar. I think it's just generally this hill, and it leads up to Bhavnath. I think it leads up to here. Like, it's all of this leading up to Girnar. Note that the A.K. Roy, 1957, noted that the whole hill of Jatasankar, quote, is magnetic from the base to the top with segregated pockets of magnetite deposits, end quote. Roy, 1968, the same people. The author found magnetite deposits at the western side of the northwest ridge near Bhavnath Temple at the foot of Jatasankar Hill. Some reason there's like a high magnetism over here, basically. Which, if we look at the currents, again, there's this vortex here. Maybe related to that there's a current coming in this way, crossing with the current coming this way, creating like just a vortex here that just sort of makes, for whatever reason, magnetic materials gravitate to that location specifically. I don't know. That one's a little odd to me in terms of how to explain it beyond what I just said in a way that I feel is more like absolutely makes sense. Like, that's kind of like that could be said anywhere. Like, I could say that for over here, be like, well, yeah, so the currents brought and so like there was a cross current here, there's a cross current here. So like it doesn't necessarily fit. It may be related to that this current over here is pushing this way and just generally pushing into the further side, less into this side, and maybe creating like a backstop to Girnar itself here. That maybe is what's going on with the magnetic aspect of it. I don't know what to make of it, but okay. Just thought I'd mention it, add it to the list here of the hill names, because then it's labeled pretty well, and I can just keep adding labels of hills. I found some more names. I don't know where they are though. So it is believed that the Calcareous, this is Biswar's 1971, I think, Biswas, something. It is believed that the calcareous sands of the Kathiawar coast, rich in marine organisms, were blown by wind torn towards the northern region by a persistent wind current blowing towards the northwest. So, apparently, as I'll read the next one too. After a certain interval, this is Subba Rao, I believe this is about it. I believe, yeah. After a certain interval of geological time, super around 1970A, after a certain interval of geological time, when the present-day topography had nearly developed, so when this was all generally formed already, the low-lying areas were submerged by an incursion of sea deposits, sea depositing limestones. The general deposition of limestone is nearly flat or gently sloped towards the sea. So, after Girnar was formed, let's go to this one. The storm is moving this way. Lightning strikes Girnar into being, but then it's over here and it moves off this way, and it's gonna be then putting winds this way over top the water. So it starts to take this water and just shove material across the land that then deposits across Girnar, as well as all of the Kathiawar plains, really, and perhaps even up into other regions. Okay. Okay, this is the last one. Last one, but it's kind of interesting. Kind of interesting. I guess kind of interesting. If I can zoom in here. If I can zoom in. Okay. Osam Hill. I found some notes on Osam Hill, which are also from John Wiener's book, 1925. Krishnan, 1925, on Osam Hill. The Osham, or Osham, also with an H. The Osham Hill consists of. Consists also. The Osham Hill consists also of widely divergent products of differentiation within basic rocks in the southwest and acid lavas in the northeast. Some of the latter are banded, the northeast lavas, and are banded and show flow structure and contortions in the hand specimens. This location has an inflow this way, which then runs into the sea boundary, which is kind of interesting. So as it's coming in, it's termed the northeast side, like this where this current is just running into it. So let's pull up the actual map. Here's Osham Hill. The current that's coming across from this arrow, across here, wrapping around here at the border of as far as it can go, basically, is essentially along this line. And I guess also into around some boundary point here, maybe. I don't know. To a point where it has like a current cutting across here, basically, and just cutting right through here and pushing material this way. But then there's another current cutting that when it passes there, it hits this wall, builds up material, turns around, and comes back this way. And so when it comes back, it then again cuts across it here to essentially wrap around, I guess. Like these probably even overlapped a bit. Maybe that their overlapping even led to like material being deposited from it, from this current, bringing like, as this current passes into this current, it causes like a conglomerations of larger things that then this current brings along with it back to deposit it here, maybe, I don't know, to essentially build up a little nook body here that just built up, and then also the current that's coming back around here to just finish off this thought. Then also wraps around, like that hits it, it bends around it. Instead of just like hitting it, it meets enough resistance that it pushes into it and bends or deflects around it, and just causes a vortex over here, in essence, a swirling region that then influences this side. That even makes sense for why now that I look closely at it, why it has like this structure going on, maybe a little eddy in there formed, and then like stepped. Whereas this side is much more just like chunk, just straight across almost, a little bit of indentation now, or whatever you want to call it, but protrusions, but. Where this side looks like it maybe the current was not so, like it kept hitting the wall and coming more away that way. That doesn't seem to make sense. That doesn't seem to make complete sense of the things I'm saying just off the top of my head, because it kind of seemed, unless this one here, when it like the segment that connects with this current just kind of bleeds a little chunks this way that then build out there. I don't know. Because that doesn't make complete sense to me. But that maybe makes enough sense to just be like, maybe that. I don't know. Let's get that out of here. Load. But so, it's northeast. So, I guess this side, I don't know, like northeast, maybe here and here. That would actually make sense. Like these two sides are kind of the northeast sides. I'm not sure. But then it says has basic rocks in the southwest, acid lavas, rocks in the northeast. So there's some sort of differentiation going on. I guess it doesn't need the lava themselves to be different. It just needs that there's different pressures that are causing a separation over here. Maybe the more dense material is got over here, and these are the less dense ones, but still it's like a pile. Kind of like Girnar, but like here, but with like this segment here that's kind of got gabbro. Like the flow is coming in here and just building a wall of the most dense stuff, where the less dense stuff is getting chipped away a bit. I don't know. Okay, with that in mind, that's it for now. I do hope we can talk about this, guys, at your leisures.